our second unit and measurement. We have already discussed about the introduction and the international system of unit. Now our third topic is measurement of the length. In the measurement of length, we can we discuss about the meter scale, vernier calipers, micrometer, screw gauge, and the spirometer. Okay, by we can measure by length, height, breadth by using the meter scale. Okay, so using the meter scale, we can measure just as a 10 raised to minus 3 to 10 raised to 2 10 raised to 2 meters by using meter scale. So it is a range of the meter scale. Now it will gives us the smallest value of meter scale is 0.1 mm. So in the scale, you in your scale you can show the smallest value of it is after zero, after starting of 0 you have one line, then after second line, then after third, fourth, and the fifth is the large, then after 6, 7, 8, 9, and 10 is the large line. Okay, at the 10 number line it is a 1 centimeter. Okay, so we can measure the smallest value of meter scale is 0.1 mm. Okay, so it is a small LCM of the meter scale. Then after we have a micro vernier calipers. Okay, in the vernier calipers it has a two scales. First of all, it has a vernier, it has a main scale, and then after we have another scale. On the scale is vernier scale. Okay, in the vernier scale has a 10 digits. In the vernier calipers has a 0 to 10 digit, another 0 to 10 digit on the vernier scale. So by using the vernier calipers, we can measure smallest value. LCM of the vernier calipers is 0.01 mm. So it is more precise than the meter scale. Then after by using the meter scale, we can measure the diameter. We can measure inner diameter, outer diameter of the ring, or by using by using the height. It has a three it has by height. Okay, then after we have micrometer, screw gauge. In the micrometer, screw gauge, we can measure smallest value of 0.001 mm. So it has a 0.001 mm. It is more precise than the vernier calipers as well as the micrometer as well as the meter scale. So micrometer, screw gauge, and also spirometer has a same range, 10 raised to minus 5 meters. So it will measure it can measure 0.01 mm. Okay, it is a direct measurement of the length. It has a direct method. Now but we cannot measure the large distance, we cannot measure the large range of beyond this range. We cannot measure by using the meter scale, micrometer, screw gauge, vernier calipers. So we need to another method. It is called the indirect method. Special method is called the indirect method. Okay, in this indirect method we can show we can show measurement of the large distance. For the measurement of large distance, in the large distance, see the large distance such as the distance of planet or stars from earth cannot be measured directly with a meter scale. An important method in such case that is the parallax method. Now what is the parallax method? We have discussed about the parallax method, but first of all, what is the parallax? We need to understand what is the parallax. So first of all, we are doing the just one we can doing just one experiment from by insights. Okay, by insights, when you hold a pencil in front of you against some specific point. Okay, some specific point on the background wall, and look the pencil first through your left eye, closing the right eye. Okay, and then look at the pencil through your right eye, B, closing the left eye. Okay, you would notice that the position of the pencil seem to change with respect to the point on the wall. This is called the parallax. Okay, this is called the parallax. The distance between 2 points of observation is called the basis. Now here we have a distance between, here we are discussing about the distance between two observation. So how we have a only just to observe, we have, how we have a observation. So we have a two observation, yes, we have also two observation, one I1 and the IA, and we can, so IA and the IB. Okay, left eye is the A and the right eye is a B. Okay, so we have A and B, it is a observation, it is a two observation point. Okay, we have two observation point. So now distance between IA and IB, distance between two eyes, it is called the basis. Okay, it is called basis. It is, in this example, the basis is the distance between the eye. Okay, to now we are discussing about the to measure the distance of far away planet as by the parallax method. Okay, we have a far away, so we have a planet, lots we have a planet. So okay, so we need to measure the distance between earth and the planet. So in this phenomena, we can measure the distance d of a far away planet as by the parallax method. We observe it from two position. Okay, first of all, on the earth, by using the two position, we can measure the distance, and as well as we have angles. Okay, so we observe it from two different position, A and B, on the earth, separated by the distance AB. Okay, it is equals to B. Now how it will comes? So after that I explain, and after that, first of all I explain. So the time, so in figure 2.2, now in figure in figure, so here the distance A and the B. Okay, A and B, it is the two observation point from the earth, and S is our planet. Okay, and the D is, capital D is the distance between point A and point A, and also point A to S, and as well as the point B to S. So in this topic, we shows the figure 2.2. We measure the angle between two direction along with the planet is viewed these 2 points, the ASW, in figure 2.2. Now also we have a one angle theta. Okay, between the S. So S has a to S and a B to S. We between these two different position of observation, we have angle theta. So this angle theta, it is represented by the AW, angle ASW, in the figure 2.2, represented by the symbol theta. It is called the theta. Okay, now this angle is known as the parallax angle or parallelistic angles. Okay, so as the planet is a very far away from be away, so we know that it is a lots of light years away from the earth, so it is a large distance. But we have our observation distance between 2 point, it is just so small, so small. So less it will gives us to less or more or less 1. Okay, so it will 0 point something values. So therefore we conclude that theta is very small. Okay, so we have discussed about the theta is very small. So then we are approximately taken AB as and the arc of length. Okay, now here we are discussing about the arc of length. So we have just consider as is the center of circle. So we have now what we consider, that here the S is the center of circle, and the distance D is the radius of the our circle AS, or is our circle. Now here AS is equals to BS, so that AB is equals to B, and also D theta, where theta in is the radian. Okay, now so here shows that D is equals to B upon theta. Now having the diameter D, we can employ a similar method to determine the size of an angular diameter of the planet. If D is the diameter of the planet and alpha the angular size of the planet, the angle subtended by the D at the earth, we have alpha D. Alpha is equals to small d upon capital D. The angle alpha can be measured from the same location on the earth. It is the angle between two direction when two diametrically opposite point of the planet are viewed through the telescope. Since D is known, the diameter Since d is known, the diameter d of the planet can be determined using this equation 2.2. Okay, equation using 2.2, alpha is equals to small d upon capital D.